بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Our chapter today talks about inequalities. Let's begin. A first-degree polynomial is a polynomial of the form p of x equals ax plus b, where a and b are two real numbers and a is never zero. Because remember, if a is zero, p of x would be b and it will not be a binomial of first degree. Now, how do we find the sign of a binomial of first degree? First, we have to find the root of p of x. In other words, we set up ax plus b equal to 0 to find that x is minus b over a, and then we draw a table of signs or a sign table as follows. This is x. X varies from minus infinity to plus infinity. We have to put this root here, and this is p of x. Because this is a root, we put a 0 here, and then we write the signs as opposite sign of a and same sign as a. Remember, this is a. Let's take some examples. We need to study the sign of p of x in each of the cases. This is the first case, so remember, first we have to find the root and then we draw the sign table. Now the root in this case is, if x plus 2 is 0, x would be negative 2. So this is the root. And then to fill in the signs, we have to look at the sign of x. And the sign of x in this case is positive, as you see. So we fill in the signs as opposite sign of a, same sign as a. Let's see another example. P of x is also a binomial of first degree. Find the root. If minus 3x plus 9 is 0, the root would be 3. That's it. And then again and again we look at the sign of a, and a in this case is negative 3. So we fill in the table by opposite same. The sign of a is negative, so this is positive, this is negative. Let's take a third example. In this case, if minus 10 minus 2x is 0, so x would be minus 5. This would be the table. Remember, in this case, this is a, because a is the coefficient of x. It's negative, so we have to fill in the table by opposite same. In other words, we use opposite of minus, which is plus, and then the same as minus, which is a minus. Now let's see some applications. In this case, you would do the application alone using pen and paper. Please try to pause the video to work out the example and then try to see the answer. Now let's see the second application. We need to solve each of the inequalities below. Remember, to solve an inequality with degree 1, we isolate x, then we simplify. Let's see. This is an inequality. We need to solve it. In this case, we isolate x. In other words, we put the x's on one side of the inequality and the numbers on the other side of the inequality. Now, in this case, we have 6x minus 18 is less than 0, so 6x is less than 18, x is less than 3. Now, minus 4x minus 24 is greater than or equal to 0. Now, minus 4x minus 24 greater than or equal to 0, so minus 4x is greater than minus 24, and x is smaller than minus 6. Remember, here in inequalities, when you multiply or divide by a negative number, like in this case we are dividing by negative 4, you flip the inequality sign. You see, the inequality sign was greater than or equal to 0, so we flip it into smaller than or equal to 0. Now, in this case, it's also an inequality of degree 1. And always remember that in case of inequalities of degree 1, we isolate x, then we simplify. So we get x is smaller than 1. Now let's see the sign of a trinomial of second degree. A second degree trinomial is of the form p of x is ax squared plus bx plus c, where all a, b, and c are real numbers and a is never 0. Because again, if a is 0, p of x would be bx plus c, and it will be a binomial of first degree. Now remember, in this case, we have to calculate the discriminant delta, which is b squared minus 4ac. And in fact, the sign of p of x depends on the sign of delta. Remember, if delta is negative, we have no real roots. If delta is 0, we have one double real root, which is x1 equals x2 equals minus b over 2a. And if delta is positive, we have two distinct real roots as follows. Now, how do we find the sign of p of x? As I said before, it depends on the sign of delta. Remember, in case delta is negative, you will not have any root here, and the sign of p of x would be the same as the sign of a, and this is a. It's the coefficient of x squared. Now, if delta is 0, we're going to have only one root, which is double root. This is the root, and this is the 0. And also here we have to use the same sign as a and the same sign as a. Till now, dear students, we have three same signs. Now, in this case, in case we have two distinct real roots, we're going to have two roots here. And to fill in the signs, we use same, opposite, same. So you see, in this case, we have same, 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 but we just have an exception here, which is the opposite. And this exception happens in case delta is positive. Now let's see some examples. Study the sign of p of x in this case. This is a trinomial of second degree, so we have to find delta, and we can also use the calculator to find the roots. Now, using the calculator, we have two roots, which are 1 and negative 4. And in case we have two roots, this means that delta is positive, and we are in this case. So, we draw the table, we put the roots in increasing order, negative 4 and then 1. These are two zeros, and then we want to fill in the signs. Remember, in case delta is positive, we have to use same, opposite, same. Now, the coefficient of x squared in this case is positive, so the formula of same, opposite, same works as plus, minus, plus. Let's see another example. This is also a trinomial of second degree. The roots are, we have in this case no roots, and we can tell by using either delta or the calculator. Now, in case we have no roots, we have to use the same sign as a, and a in this case is negative, as you see. So we put a minus. Now, a third example, the roots, we just have one double root, which is x equals negative 2. So we are in the second case, same, same. And this is plus, this is plus. Remember, the same sign as a. Remember again, we have the same sign when delta is negative, the same sign when delta is 0, and we have same, opposite, same when delta is positive. Now, specifically in this case, if we just take 2 in common, we get x squared plus 4x plus 4, and this is an identity. This is the same as 2 into x plus 2 quantity squared, which is always positive or equal to 0. And this is what we get in the sign table. Now, please try to do these applications alone and try to pause the video while working. Okay, now let's see the solution of a rational inequality. Remember, to solve an inequality which is not of degree 1, we compare to 0, we factorize, we find the roots, we construct a sign table, and then we find the result. Let's see what do we mean by this chart. Now, we have this expression. We need to solve the inequality. This is in fact an inequality which is not of degree 1 because we have x in the denominator. So it's not of degree 1. We have to follow this chart. First, we compare to 0, and it's already compared. Second, we try to factorize. Now, if we just take x as a common factor in the numerator, we get x into x squared plus 1. Now one might say here, why don't we continue factorizing x squared minus 1 as x minus 1 into x plus 1? It works, but I always advise you when it comes to degree 2 to leave it, because degree 2 has its own formulas. Now we find out the roots. In the numerator we have x equals 0, x is 1, and x is negative 1. In the denominator, now the first factor doesn't have any root because delta is negative, and the second factor, the root of the second factor is negative 3. But remember, we put it as x doesn't equal negative 3 because it is in the denominator. Now we draw the sign table. This is a very huge sign table. You see here we have to put all the numbers in increasing order. The numbers that we have, the roots that we have, are negative 3, 0, 1, and negative 1. So we put them in increasing order. Now here we put all the factors, and in fact we have x squared minus 1, we have minus x squared minus 4, and we have 2x squared plus 12x plus 8 as factors. Now, how do we fill in the signs in the table? This, in fact, depends on the formula that we've just seen. This is of degree 1, so we have to put opposite, same. This is of degree 2, and it has two roots. Degree 2 with two roots, we use same, opposite, same. And this is of degree 2, as you see, but it has no roots. And in case we have degree 2 with no roots, we have to use the same sign as A. And this case is of degree 2 having only one root, so we also use same. And this would be the final answer by multiplying and dividing all of these signs. Now we need the inequality to be negative or equal to 0. Now being negative, we choose the negative cases here, and equal to 0, we choose all the zeros. Now, what do we mean by this? This is negative, so x in this case would be between negative 1 and 0. And this is also negative, which means that x is between 1 and plus infinity. Now this is the answer. Now, because we need it to be negative or equal to 0, so we have to choose also the zeros. So this 0 will be included at minus 1, so we close the interval. And this 0 would be included at 0. We close the interval. And this 0 also would be included at 1, and we close the interval. Remember, please, the interval would always be opened in case we have infinities and impossibilities. So always remember, please, this chart. Now, we want to solve this inequality. Now, this is an inequality whose degree is not 1. Remember, because x is in the denominator. So the first step is to compare to 0. This is what we mean by compare to 0. It means we have to take x from the right side to the left side of the inequality. And then we take a common denominator. We find out the roots. The roots of the numerator are negative 1 and 3. In the denominator, we have to state that x is never 1. Now, the fourth step is to construct a sign table. This is the sign table. Remember, again and again, the roots should be stated, should be written in increasing order. Now, this is of degree 2, and it has two roots, so we use the formulas same, opposite, same. And this is of degree 1. This is the root, we use opposite, same. Now, I want the answer to be greater than or equal to 0, so we have to choose the pluses. In other words, x should belong to negative infinity, negative 1. This is the first plus. Union, the second one, which is 1, 3. Now, this is greater than or equal to 0, so we have to choose the zeros. Negative 1 should be included, and the 3 should also be included. This is negative 1, this is a 3. Remember, 1 should never be included because we have an impossibility here. Now, please try to do this application alone.